Hey guys, today we are going to continue to look at operations with scientific notation. We're going to answer the question, how do I add and subtract numbers in scientific notation? So to add or subtract numbers in scientific notation, the numbers must have the same exponents. So the first thing that you need to do is check to see if they have the same exponents. If they do not have the same exponents, then you will use LARS, which is left add, right subtract, to shift the decimal left or right and change the exponent with addition or subtraction. Then once we have the same exponents, you will add or subtract the coefficients and then keep the common exponent. And then you just need to make sure that the final answer is in correct scientific notation form with that coefficient between 1 and 10, and if it's not correctly written, then we will use LARS again to convert it to correct scientific notation. So let's look at number 1. First thing you want to check for is the exponents, which they are the same, so I can go ahead and add my coefficients. So 5.2 plus 3.1 is 8.3. And then we keep the exponent, so times 10 to the second. And 8.3 is between 1 and 10, so we are good. All right, let's look at number 2. I have 10 to the third and 1.1 times 10 to the second. So these are different. So I need to change one of them to be either 10 to the third or 10 to the second. So whenever I run into this situation with addition, what I'm usually going to do is in LARS, I want to try and do the LARS part, because if I move a decimal to the left, it'll make it smaller, and it just means less chance of that number being bigger than 10. So you can either change this to a 10 to the second or change this to a 10 to the third. You can do either one. I'm going to go ahead and change this to a 10 to the third just because I think it'll mean less steps down the road, but either one works. So I'm doing left add with this number right here. So I'm going to move left and then I'm going to add to this exponent. So it'll be 8.3 times 10 to the third. That's going to stay. Plus, I'm moving that decimal left, so it'll be 0.11 times 10 to the third. Okay, now these exponents are the same, so I can add the coefficients. So 8.3 plus 0.11 is 8.41. And then it'll be times 10 to the third. And now that number is between 1 and 10, so we are good. Okay, I have different exponents here, so I need to change one of them. And remember, when we're adding, in general, we want to try and move a decimal left so that the coefficient doesn't get too big. So I want to add to this one right here to make it 8. So I'm going to move this decimal left here, and then I'll add here. So it'll be 0.75 times 10 to the 8th plus 2.1 times 10 to the 8th. So 0.75 plus 2.1 is 2.85. So I get 2.85 times 10 to the 8th. Okay, let's look at number 4. So my exponents are not the same. I want to try and get them the same, so I'm going to use LARS. So I want to try and use left add whenever I have an addition problem. And if I add, remember it's negative, so it's a little bit backwards. If I add to this one, it would become -3. If I add to this one, it would become -4. So I'm going to change this second one. So I'm going to move this decimal left, and then I'll add 1 to that exponent. So the first one's going to stay the same. It'll be 4.3 times 10 to the -4th plus 0.23 times -5 plus 1 is -4. Okay, so now I can add the coefficients. 4.3 plus 0.23, I get 4.53. And then I'll keep the exponent times 10 to the -4th. Okay, number 5. So these are 2 apart. So what I'm going to do is I'm going to subtract from this one and add from this one, and then it'll get both of them to be 7. So I'm going to have to use a part of Lars on both of them. So I want to subtract from this exponent, so that means I'm going to have to move this to the right. So it'll be 35 times 10 to the 7th. Plus, I need this exponent to be a 7, so I need to add, so I'm going to move this decimal to the left. So it'll be 0.27 times 10 to the 7th. So now I add the coefficients. 35 plus 0.27 is 35.27 times 10 to the 7th. And then this number is not between 1 and 10. So I need to move this decimal to the left to make it between 1 and 10, which means, according to Lars, I will add to that exponent, and I will get 3.527 times 10 to the 8th. Okay, number 6, I have a 5 and I have a 6, so I'm going to need to use Lars to adjust so that I can get the same exponent. I'm going to do left add with this first one. So it'll be 0.999 times 10 to the 6th plus 8.88 times 10 to the 6th. So now I can add the decimal coefficients. 0.999 plus 8.88 is 9.879, and then times 10 to the 6th. Okay, so those were the addition problems. Now I'm going to do some subtraction problems. So number 7, these exponents are already the same, so I can just go ahead and subtract the coefficients. So 8.3 minus 4.3 is 4. And then we will keep the times 10 to the 7th. Okay, number 8, same exponents again. So I just need to subtract the coefficients. So 9.59 minus 2.32 is 7.27. And then I'll keep the times 10 to the negative 2nd. Okay, on number 9, my exponents are not the same. So let's think about Lars. So generally what I want to try and do with subtraction problems is keep the first coefficient larger than the second coefficient, because I don't want to end up with a negative coefficient in scientific notation. So I'm definitely not going to try to make this any bigger by going right and then subtracting. So what I'm going to do is I'm going to change this one. So I'm going to move the decimal left, which will make this number even smaller, and then I will add to that exponent. So I'll get 7 times 10 to the 10th minus 0.2 times 10 to the 10th. So now I'm going to do 7 minus 0.2, and I get 6.8, and then times 10 to the 10th. All right, number 10. So let's think about Lars, and I want to try and keep the first coefficient larger. So I have 12 and 11. So I'm not going to move this to, I guess I could move that to the right and then subtract from here. But I'm just going to make this even smaller by moving the decimal to the left, and then I'll add to this exponent here. So it'll be 5.7 times 10 to the 12th minus, move it to the left, 0.16 times 10 to the 12th. So now I subtract the coefficients. 5.7 minus 0.16 is 5.54. And then times 10 to the 12th. Okay, number 11, need to do Lars again. I am going to use right subtract on the second one just to make sure that it is smaller. Or I'm sorry, I'm going to use left add to make sure that this coefficient is smaller. So we'll move this decimal to the left and add. So the first one will be 9.3 times 10 to the fifth minus, we move it to the left, so 0.27 times 10 to the fifth. So 9.3 minus 0.27 is 9.03. Okay, and last one, they are 2 apart. So what I'm going to do is I'm going to adjust both of them. I'm going to turn this one into a 4 by subtracting 1, and I'm going to turn that one into a 4 by adding 1 with Lars. So on this one, I need to subtract, so I'll move the decimal right. And then on this one, I need to add, so I will move the decimal to the left. So this first one will become 39 times 10 to the fourth minus, the second one will become 0.61 times 10 to the fourth. So now I'm going to do 39 minus 0.61, and I get 38.39 times 10 to the fourth. And then this number is not between 1 and 10, so I need to fix it with Lars. I need to move the decimal to the left, so I'm going to add to the exponent. It'll be 3.839 times 10 to the fifth for the final answer.